In this video, we will learn about the insertion sort algorithm and how to implement it using C++ code. Insertion sort works the same way as many people would sort a hand of playing cards. For example, let's say we have a hand of the following cards: King, 7, 5, 3, and Queen. Going from left to right, we can move the 7 before the King, since it has a lower value. Then we will move 5 to the beginning, since it is the lowest value we've considered so far. Next, we will move 3 to the beginning of the list. Finally, we move the Queen between the 7 and the King. Now all of the cards are in order, according to their value. Now, let's look at a conceptual example applying to numbers. Say we have the collection we've been using as an example in these videos, made up of the numbers 20, 10, 50, 2, and 5. We would move 10 before 20. Then we would leave 50 where it is, since it is the highest out of the numbers we have considered so far. Then we move 2 to the beginning of the list, and finally we place the 5 between the 2 and the 10. Now the numbers in the collection are in order. Now that we understand what an insertion sort is, let's learn how to implement the insertion sort algorithm using C++ code. Next, we will create a function with a void return type named insertion sort that takes in two parameters, a vector of integers named list and an integer named length. Don't forget to add the ampersand before the word list so that we can sort our vector in place. Inside of this function, we will have a for loop that starts at int I equals 1, runs while I is less than length, and increments I by 1 each time. Inside of this for loop, we will create an int variable named current that we set equal to list at index I. Then we will create an int variable named sorted index that we set equal to I-1. After that, we will have a while loop that runs while sorted index is greater than or equal to 0, and list at sorted index is greater than current. Inside of the while loop, we will set list at sorted index plus 1 equal to list at sorted index. Then we will set sorted index equal to sorted index minus 1. Outside of the while loop, but still inside of the for loop, we will set list at sorted index plus 1 equal to current. Inside of C++'s main function, we will call the insertion sort function on our numbers list, and pass in 5 as the second argument since our list has 5 elements inside of it. When we run the code, notice that the elements in the list were successfully sorted. In this video, we will learn about the Radix sort algorithm and how to implement it using C++ code. A Radix sort looks at each decimal place when ordering numbers, going from right to left. For example, let's say we have the numbers 401, 105, 120, 310, and 402. The rightmost digit of each element gets compared, and then elements get ordered based on that. Since 120 and 310 have a 0 at the end, they come first. Then comes 401, then 402, and finally 105. So now the list is sorted when looking at only the rightmost digits in the numbers. The Radix sort then orders the numbers based on their middle digit. When considering the middle digit in each of the numbers, they get arranged in the order 401, 402, 105, 310, and 120 respectively. Finally, we examine the leftmost digit of each of the list elements and order them according to those. Now the elements get rearranged to the order 105, 120, 310, 401, and 402. This completes the Radix sort algorithm, and now the list elements are in order. Now that we have a conceptual understanding of how the Radix sort algorithm works, let's learn how to implement it using C++ code. Next, we will create a function named counting sort that takes in 3 parameters, a vector of integers named array, an integer named size, and an integer named place. Inside of this function, we will create an int variable named 10 that we assign the integer value 10. Next, we will have an int array named output with a size of the size parameter passed into the function, and then we will have an int array named count with a size of 10. After that will come a for loop starting at int I equals 0, running while I is less than 10, and incrementing I by 1 each time. Inside of this for loop, we will set count at index I equal to 0. Next, we will have another for loop that starts at int I equals 0, runs while I is less than size, and increments I by 1 each time. Inside of this for loop, we will increment the value of count at index array at index I divided by place modulus 10. Then we will have another for loop that starts at int I equals 1, runs while I is less than 10, and increments I by 1 each time. Inside of this for loop, we will assign count at index I to count at index I plus count at index I minus 1, using the plus equals operator, so that the addition and assignment happen in one step. For int I equals size minus 1, while I is greater than or equal to 0 and decrementing I by 1 each time, we will set output at index count at index array at index I divided by place modulus 10 minus 1 equal to the array at index I, and then decrement count at index array at index I divided by place modulus 10, using the minus minus operator. After that, we will have another for loop starting at int I equals 0, running while I is less than size, and incrementing I by a value of 1 each time. Inside of this for loop, we will set array at index I equal to output at index I. Next, we will create the function that is actually responsible for performing the radix sort. Let's create a function with a void return type that takes in two parameters, a vector of integers named list and an integer named size. Inside of this function, we will create an int variable named max that we initialize to a value of -1. Then we will have a for loop that starts at int I equals 1, runs while I is less than size, and increments I by a value of 1 each time. Inside of this for loop, we will check if list at index I is greater than max. If so, we will set max equal to list at index I. At the bottom of the function outside of this for loop, we will have another for loop that starts at int place equals 1, runs while max divided by place is greater than 0, and multiplies place by 10 on each iteration of the for loop. Inside of this for loop, we will make a call to our counting sort function and pass in list as the first argument, size as the second argument, and place as the third argument. Inside of C++'s main function, we will make a call to the radix sort function that we created, and pass in numbers as the first argument, and 5 as the second argument. When we run the code, notice that the elements of our vector were properly sorted, thanks to the radix sort algorithm that we implemented.